Hello everyone, welcome back to another lesson. Today's learning goal is I can solve quadratic equations by factoring and applying the zero product property. Okay. The zero product property, as we'll talk about, it means that it's the property that where a times b equals 0, then either a equals 0 and or b equals 0. So one of these two factors, in order for them to multiply to 0, one of these two factors has to be 0. A quadratic equation is a polynomial equation of degree 2 which can be written in the standard form ax squared plus bx plus c equals 0. Like linear equations, quadratic equations can be solved to determine the value or values of x that make the equation true. Okay. There are various methods to solve for quadratic equations. If the polynomial is factorable, the following method can be used. So, it says, step 1, if necessary, rewrite the equation in the form of ax squared plus bx plus c equals 0. Factor the polynomial. Then use the zero product property to set each factor equal to 0. That is, if a times b equals 0, then either a equals 0 or b equals 0. Okay. And then write and solve each equation for x. So here we have x squared plus 3x minus 10 equals 0. We've got to figure out what value of x makes it so that it equals 0. Now, it says we're going to solve by factoring, okay? Which means we've got to set this equation equal to 0, but it's already set it equal to 0, so we don't have to do that. Then what we're going to do is factor this, so we're going to find two numbers that multiply to negative 10 and add up to 3. Well, that would be x plus 5, x minus 2. And those two things equal to 0. Now, what we have to do then is figure out what makes each one of these binomials 0. What value of x makes each one of these binomials 0. Because if we get this binomial to be 0, then it doesn't matter what this is, because 0 times any number gets us 0. Or if we get the other binomial to be 0, doesn't matter what this is, then 0 times that number gets us 0 as well. Okay, so in order to do that, we're going to set each one of those binomials equal to 0. Well, x plus 5 equals 0, and x minus 2 equals 0. And x plus 5, if we subtract 5 from both sides, gets us that x should equal negative 5. If x equals negative 5, then this becomes 0. And that'd be 0, and then if I plug in negative 5 right here as well, that'd be times negative 7, and 0 times negative 7 equals 0, so that works. On the other side, if we add 2 to both sides, we find that x equals 2, so that means that if I plug in 2 to both sides of both of these binomials, that makes this 7, and this 0, and 7 times 0 is also 0. So that means that we did it correctly. We can also plug it back into our original equation right here. So that'd be negative 5 squared, which would be 10, or excuse me, 25, plus negative 15 minus 10 does in fact get us 0. Same thing for if we did that with 2. 2 squared is 4, 3 times 2 is 6, minus 10 also gets us 0. We're going to solve this one by factoring as well. Here, we have 5x squared plus 15x. And we factor her first by our greatest common factor, which is 5x. And that gives us x plus 3. These two things equal 0. We have our factors right here and right here. And so we're going to set both of those equal to 0. Divide both sides by 5. We find that x equals 0 is one solution. And x plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. So that means if I plug in either 0 or 3 for x in here, they should both give us a final answer of 0. So if I plug in 0 right here, that'd be 5 times 0 times 3, which is 0. So that works out. And if I plug in negative 3, that'd be 5 times negative 3 times negative 3 plus 3. And negative 3 plus 3 is 0, so that's just 5 times negative 3 times 0, which is also 0, so that works out. Go ahead and solve this one by factoring as well. What you should have found is that x equals negative 3 and x equals negative 4, because this equation factors into x plus 3, x plus 4 equals 0. So, notice that when we're solving quadratic equations, we're replacing the y value with 0. For example, question 3, which is this right here, question 3 can be rewritten as y equals x squared plus 7x plus 12, with y equaling 0. So essentially, since we're replacing the y value with 0, what we're actually finding is the zeros, or the x-intercepts of the quadratic function. So right here is a graph of x squared plus 7x plus 12. Okay, so this is this right here. And remember, in order to find the x-intercepts of any equation, we're going to plug in 0 for y. And so 0 equals x squared plus 7x plus 12, which is the problem that we had in question number 3. And notice that the x-intercepts are right here and right here at negative 4, 0, and negative 3, 0. So what we're actually doing here is we're finding the x-intercepts, okay, by setting y equal to 0. The graph to the right shows the function y equals 2x squared minus 3x minus 9. Using the graph, estimate the zeros of the function. Well, we can see that here it kind of looks like it's going through possibly negative 3, 0. And then over here, maybe it's negative 1.50 approximately. Okay, so here it says those are going to be our estimates. It says write the quadratic equation to find the zeros of the function and then solve by factoring. So we're going to set this equal to 0. So y is going to be 0. We're going to 0 equals 2x squared minus 3x minus 9. Okay. And we're going to solve this by factoring. Okay. So we're going to have to find two numbers that multiply to negative 18, because 2 times negative 9, 18, not 81, 18. And multiply or add up to negative 3. So our answer is going to be positive 3 and negative 6. So we're going to split this 2x squared plus 3x minus 6x minus 9. Factor by grouping. And we get x 2x plus 3 negative 3 2x plus 3. And then we're going to factor out our binomials here. So we get 2x plus 3 and x minus 3. And we can see that our solutions are going to be negative 1/2. Because 2x equals negative 3. Divide both sides by 2. X equals negative 1.5. And over here, on the other side, x minus 3 equals 0. So therefore, x equals 3. So just like what we saw in our graph, our solutions are x equals 3 and x equals negative 1.5. Rashika found that the factors of the quadratic function h to be x plus 3 and x minus 5. What does that mean for the zeros of h of x? Well, that means that since x plus 3 is 0, when x equals negative 3, and since x minus 5 is 0 when x equals 5, the zeros of h of x are negative 3, 0, and 5, 0. To utilize the factoring method to solve, the entire equation has to be set equal to 0 in order to use the zero product property. Okay. In questions 6 and 7, rewrite the equation so it is set equal to 0 and then solve. So here, we're going to have to do that first step that we talked about earlier. It says, in order to solve, if necessary, rewrite the equation in the form of ax squared plus bx plus c equals 0. We can see that's not the case for our next two examples. This one is set equal to 14, the other one is set equal to negative 5. So we're going to have to rewrite this so that it is set to equal 0. In order to do that, we have to subtract this one by 14 on both sides. That gets us x squared plus 5x minus 14 equals 0. Then we do what we usually do. I'm going to factor this, so two numbers that multiply to negative 14 add up to 5. And that would be x plus 7, x minus 2 equals 0, which means that x equals negative 7 and x equals 2. Go ahead and try number 7 out on your own. What you should have found was that x equals negative 1/2 and negative 5. Because if we can factor that, we add 5 to both sides, we get 2x squared plus 11x plus 5. And if we factor that, we get 2x plus 1 and x plus 5. And we set each one of those equal to 0 to get negative 1/2 and negative 5.